The world is electrifying. Electric vehicles, renewable energy systems, advanced robotics, and automation. And behind every one of these technologies are three core engineering disciplines: electrical machines, control theory, embedded systems. Welcome to eMotorLabs. This is where those disciplines come together, not just in theory but in real implementation. Most engineers begin the same way. At university, you study multiple subjects at once, deadlines every week, exams every month. The system moves forward whether you fully understood the last topic or not. So the goal shifts from understanding to surviving. You memorize formulas, you pass the exam, and then you move on. But later, when you sit in front of a real motor drive system, there is no exam question guiding you. There is no worked solution. There is just hardware, code, and responsibility. This is where the gap becomes visible. Not a lack of intelligence, not a lack of effort, but a lack of structured transition from theory to real systems. eMotorLabs was built to close that gap. In industry, capability means more than having studied the subject. It means being able to design a control loop, simulate it properly, implement it in embedded C, deploy it on real hardware, and debug it when it doesn't behave as expected. That complete cycle, from equation to execution, is what employers value. And for many engineers, no one ever provided that full journey in one structured path. This is exactly what this platform delivers. First, we built understanding from first principles: how electromagnetic fields interact, how torque is produced, how machine models are derived, not rushed, not memorized, understood, because real engineering begins with clarity. Then we simulate. You build models from scratch, move from open loop to closed loop systems, tune controllers, change parameters, observe behavior. Here theory becomes intuitive. You don't just see equations, you see systems responding. And then you build it. Using professional microcontroller platforms like STM32 and Texas Instruments C2000 devices. You configure ADCs, generate PWM signals, write real-time interrupt-driven control loops, bring your simulated controller to life. By the end, you haven't just studied motor control, you have implemented it. Most resources give you fragments. University gives you theory but limited time. Online tutorials give you snippets but no system. Datasheets give you registers but no intuition. eMotorLabs was created to connect everything, built from years of experience across academia and industry, where the gap between equations and implementations becomes painfully clear. Every course follows one principle: understand it properly, simulate it carefully, then build it on real hardware. If you want structured understanding, if you want real implementation skills, if you want to build confidence with professional motor control systems, start here. Explore the free lessons, experience the method, and begin building not just knowledge but real engineering capability. eMotorLabs, from fundamentals to hardware.